checking me out. This is, I guess, already the last session of the day. Hope you had a good time so far. Yes, I see excited people waving their hands. I have a couple of statements to make before we start, to make sure that we're on the same page. Because if I detect early that we're not on the same page, I might want to quit this speaking engagement, but we'll see. Do you agree, ladies and gentlemen, that slow websites suck? Do we agree with that?
Yes.
Okay, alright, that's a good start. Do we also agree that web performance is an essential part of the user experience? If it's slow, people will just run away, get your content or your product elsewhere. Still on board? Slowdown might be considered just as bad as downtime. And if that happens, when the slowdown or the downtime happens, you lose money, you lose space, might even lose a little bit of Google PageRank. So how do you tackle these issues? Well, a lot of people just throw servers at the problem. Or as Biggie would say, he would say more money, more problems. It could be more money, more servers, in the end, more problems. So as the clever developers that we are, assume you are clever developers, we just try to identify the slowest part and figure out where the delay is coming from and essentially optimize it. That could be optimizing code, that could be optimizing your database. But eventually you'll reach that point of diminishing returns where the effort you put in to chop off some milliseconds is just not worth the development time you put into it. Because you might not realize that, but you developers are an expensive asset. So you want to keep that to a minimum. So we hit those limits, and in order to tackle those limits, you need to find a different way. And instead of trying to speed up what you build, why not cache and avoid using it in the first place? That's my opening statement. That being said, hi everyone, my name is Thijs. Thank you for taking time out of your extremely busy schedule to hang out with me for the next 45 to 50 minutes. I'm a tech evangelist at Conditional. We have a booth here, we're sponsored here. Some of you have won a dartboard with our dart game. Congratulations to you. If you're interested in continuing the conversation, just hang out with me later on. I'm Thijs Feryn on the social media, you know where those are. You can use Twitter for that to get in touch with me afterwards, or to just heckle and banter me while I'm doing this presentation. I'm perfectly fine with that. I'm also the author of Getting Started with Varnish Cache, a Varnish book that deals with the concept of caching, the topic I'm here for. It's an O'Reilly book, you can get it wherever you get it. Now, when I was in school, my database teacher told me, don't store stuff you can recompute because storage is expensive. Now that was some odd 16 years ago. Now the motto is very much different. Please don't recompute what you can store. And let's apply it to a Drupal case. If you have a Drupal website and you want to render a page, request comes in, connection gets hijacked from the web server, this gets transmitted to the PHP runtime, that might be PHP FPM. PHP is not the fastest language, nor is it the fastest runtime, it needs to bootstrap all the modules. Then the call comes into the Drupal code needs to be loaded, parsed, lexed, compiled, executed, and then we're hitting the Drupal bootstrap and so on and so forth. And essentially, or eventually, a database call will be made, data will be fetched, and we'll go all the way back. All of that, every single time, even if the data hasn't changed. So a lot of people say, oh, caching, that's compensation for poor strategies and poor architecture. I would say no, caching is an essential part of your architecture. Apply it whenever possible. There's different kinds of cache. The cache I'll be talking about is primarily HTTP cache, things you trigger with cache control headers such as these. Now, I hear you think, like, you might be silent, but I hear you think, and I hear you think, Thijs, what the hell are you doing? Playing around with cache control headers? Isn't that web browser kind of stuff? Thijs, you have no clue what you're talking about because you might not know this, but it's completely unreliable, and users might disable their cache, and it might behave per browser in a different way. Ladies and gentlemen, way ahead of you. We're not talking about browser cache, because these headers can be used for browser cache. I'm talking about applying reverse caching proxy strategies. Now, under normal circumstances, the user will directly interact with the server where your Drupal code base might be hosted. Now, if we throw a reverse caching proxy in the mix, it's just a system in the middle. And the user thinks he or she is talking to the server, and the server thinks it's communicating with the end user, whereas there's just a system in between. It takes requests from the user, translates it, forwards it to the web server, takes those responses, and if it's cacheable, it will cache them, and from then onwards, it will just be communication between those two. That's what a reverse caching proxy does. And you know what? Drupal 8 is ideally suited to do that. There are some measures it has. Look at these. In the configuration, it will have a flag, reverse proxy, true or false. And if there's a reverse proxy, it will also have the possibility to mention where that is located in terms of an IP address. And that all gets processed by this middleware right here. And here's some code from that middleware, which is quite interesting to see. So if the reverse proxy is set, you will have certain headers that will be used, like an x-forwarded for, an x-forwarded proto, might use x-forwarded host. Long story short, there are certain advantages and also certain complexities when you add reverse proxies in the mix. Because your web server will always take the IP address or the HTTP context that comes from that reverse proxy. If you don't take x-forwarded whatever, could be x-forwarded for, x-forwarded proto, all these kind of headers, into respect, you will have very flawed results. Simple point, simple case. Let's say you have a Varnish reverse proxy, TLS gets terminated before, request comes in, between Drupal and Varnish it's just plain HTTP, whereas your point of entry is HTTPS. Drupal will use the context, request context that it has to build up a URL. That URL will be an HTTP URL because it has no awareness of HTTPS. You will end up with mixed content, your browser will freak out because it sees both HTTPS and HTTP context. So it can't use that. Luckily, Drupal is clever enough to apply these headers and then the framework is aware of the fact that it's sitting behind a reverse proxy and behaves accordingly. That's how Drupal behaves out of the box. I mentioned Varnish already, there's different kinds. I'm a big Varnish fan. Yeah, I know, I already played that one out, but there's other implementations. And the goal of this presentation is to show you that this is not really strictly tied into Varnish, but if you use a reverse caching proxy like Varnish, or Apache Traffic Server, or Nginx, or any CDN available, you can apply the same principles, get the same results. Now I see, like, are you still on board? Are you still with me on this one? Because I can see people nodding yes. I see confused faces. So in that respect, let me throw this one in the mix. Who's seen this movie? Who's old enough to have seen this movie? Which movie is it for those who have seen it? Share it with the audience. The Bodyguard. Featuring Kevin Costner, yes, and Whitney Houston. Alright. Drupal reverse caching proxy. Right? Less confused now? Yeah. So, the Bodyguard protects the Drupal application from stalky fans, being excessive load on the system. Right? Unconfused now? Let's continue. Drupal 8 actually has a built-in reverse caching proxy. It's called page cache. It serves a different purpose, but it applies the same mechanisms. And it's cool because in Drupal 8, I don't come from the Drupal scene, I'm not a Drupalist, I come from the PHP scene, and I'm a bit involved with everything that in regards to Varnish caching. And I was excited to see that this is just nothing more than PSR7 middleware. And then there's plenty of methods. If you implement the handle method as you're supposed to with that middleware, all of a sudden it does a lookup, and this lookup function is called from the page cache, and it checks with this get if it's in cache or not. So all of those measures are already in place to speed up your Drupal website. But why the need for an extra layer? Why the need for extra complexity being a reverse caching proxy? Well, the reality is this is all implemented in Drupal and relies on Drupal Bootstrap, which is quite heavy, and in its turn depends on PHP, which is quite heavy, and in its turn consumes web server connections, which are quite scarce. We want to avoid using those, and if we use them, we want to use them for a very brief time. So in that respect, I would always advise you, if you can, if you have traffic on your system, put a reverse caching proxy in front of it. Some people disable page cache. In general, I repeat, in general, these collaborate just fine. Because not everything on your reverse caching proxy will be a hit, and when you renegotiate the content, it helps that the bootstrap is sped up. What I would also advise you is not always use database as your caching backend, but take something fast, take Redis for example. Now in an ideal world, this is what Google Images says an ideal world looks like. In an ideal world, let's talk about that. This might be your world if you're lucky enough. Every application is stateless. It does not depend on state. Hence, it does not depend on cookies, right? And in an ideal world, we all have very well-defined TTLs. And per resource, we say cache or no cache. Like, you all do that, right? You seem like intelligent folks. You also apply the proper cache variations, and you have conditional requests to only fetch the stuff that has changed. And you have placeholders for non-cacheable content. You all do that, I know this. I know this by seeing you here. But the reality, however, tends to suck just a bit more. It's just a bit worse. Yes, we use cookies. It's a reality. It's the way a stateless protocol like HTTP is made stateful. And even if you're tough and say, you don't use cookies, you still use cookies if you have a marketing department. If you have a marketing department, you use cookies for Google Analytics. Tracking cookies, still cookies. You still need to cope with that. Defining times to live. The regular developer is not always concerned with that. Luckily, Drupal deals with that in a certain extent. Cache variation using the vary header, not often used. Luckily, concept of cache context exists and the proper vary headers can be sent, but still, it's a challenge. And even if you have all these intentions and you want to do good, sometimes you end up with legacy that you don't want to touch. That's unfortunately the reality. So what if I told you, what if I told you you could design and develop applications that have caching in mind? Wouldn't that be great? This is my excited face. What if I told you that? What if I told you that if you're a developer, you do this all yourself, you have portability as an advantage. Portability being having a consistent caching behavior regardless of the implementation. I'm a Varnish fan. Let's say you're not a Varnish fan, you want to move it to a CDN. It should work exactly the same. Exactly. It's also a sense of developer empowerment. You have complete control and you do not depend on infrastructure implementations, which tends to be a point of failure oftentimes. You deal with hosting companies, I work at a hosting company, by the way. You deal with hosting companies, you deal with infrastructure people, ops people, vendors, and they might forget to tune something that is specific to your needs. If you apply the proper HTTP best practices, you will probably be fine. And let's go over some of those. Number 1, cache control. Now, let's do a trick here. Let's try this. This is a slide that I often put in caching talks. And I mentioned that there's a typical expires header. It works. The good old expires header mentions exactly when content is no longer valid. Now, I don't think that it's a very flexible header. I like the one below, cache control, because it explains in relative terms how long you want things to be cached. Now, with this lovely audience, I want to test your skills. I want to see how you interpret this. How long will the middle one, cache control, public, maxH, smaxH, yada yada, how long will the reverse caching proxy cache this? And the answer is 1 hour. 1 hour. That's always the one we get, every single time. And unfortunately, that's not the case. No disrespect, of course, but I was planting this one on purpose. Because the maxH is a header that we usually accept to be very dominant out there and respected by all the reverse caching proxies. Yes, that is true. If it's only maxH, then it will be an hour. But there's a thing called smaxH, and that's also part of the HTTP spec. And it states that this is solely intended for what the S stands for, shared devices, such as a reverse caching proxy. So Varnish and its competitor should give precedence to smaxH. So the answer to the question is, how long will this be cached? A day, 86,400 seconds. It will transfer that maxH header all to the front, and your browser could decide to respect the maxH on top of that and cache it for another hour. And then you have private, no cache, no store. That's just to explain that you don't want to cache private, meaning only browsers could cache it. No cache means don't serve it from cache. No store means don't store it in cache when you get your result back from the backend. That's how this is done in the wonderful world of HTTP. In Drupal, there's already an implementation, and in your backend, you'll have a generalistic way of defining the TTL, not per resource, but in general. With placeholdering, however, you could still decide with render arrays what should be loaded, how long, but this is generally not exposed to the outside world as inside Drupal. And then you get a header like this, when it can be cached, so 300 seconds, or this one, if you don't want things to be cached. I know this is pretty basic, but we still need to cover it. It's an essential part, and you should know if you walk out of here that reverse caching proxies look at these headers. It will first look at smaxH, S standing for shared, then maxH, then expires. So if you have all of them, it will take the smaxH. If you only have maxH and expires, it will take maxH. If you only have expires, it will take expires. Number 2, conditional requests. Conditional requests mean that you only fetch payload that has changed. So if you could even do it without a reverse caching proxy. If a user connects to the web server and already has that page and refreshes that page, it needs to know, has the data changed, has it not changed? If it has changed, or if you have no concept of conditional requests, you'll always return a 200 OK. even if you refresh the page and nothing has changed. There is, however, a header, or a status code rather, in HTTP that will tell you that data has not changed. Any idea? Tumbleweed, dead silence. 200 OK is when it has changed. When it has not changed, it is a, give it a try, we're among friends here, there's no, well, close enough, 304, not modified. And what it does is it returns that status code, it returns all the headers of the response, but it doesn't return the payload. The body it does not need to return because it says, hey, what you have is good, we already have it. And how does it know that data hasn't changed? Well, it uses two mechanisms for it. Number one being e-tags. E-tags are very useful for that. An e-tag is basically a fingerprint of your response. And the way I implement it, usually, is by just taking an MD5 hash of my body. That's usually the e-tag. Now, you could compose it as you wish, as long as it's there and it's unique for that resource that you're returning your file. Now, a regular browser will then store that e-tag, will serve it up upon every subsequent request as a request header under the form of if none-match. And that if none-match will carry that e-tag value for you, and then it's your responsibility. Then it's your job to validate that. Okay, I'm having this URL, this is my homepage, / I have this if none-match header, and then you should match it up to the e-tag you're about to return. If it's exactly the same, the fingerprint is the same, meaning the content hasn't changed. 304 not modified. The advantage you have is double. The advantage you have is that, on the one hand, you don't have to carry through all that data over the wire, so you reduce your bandwidth. But nowadays, bandwidth comes cheap. The actual value is if you validate early enough and quit early enough once you know it hasn't changed, you don't have to bootstrap the rest of your application, and you actually save on memory, save on CPU, save on I/O, basically generate less load on your system. There's another instrument that does very much the same thing. Last modified headers, returning the exact date in GMT format when data has changed, and it then gets transported as an if last modified header. And then you do the same negotiation. Is the time more recent than the other? If so, if not, 304, 200, yada, yada, yada. You know this. Now, reverse caching proxies can also deal with this. And reverse caching proxies could, when they have to revalidate, when content becomes stale, meaning the TTL has expired, when it revalidates it, it could also transmit that if non-match header, and you could save up on bandwidth and on RAM and on CPU and the whole business. Now, the time that it takes to revalidate for a user, the user doesn't pay a penalty for it. Like in the implementation of Varnish, Varnish will just serve up old content and serve stale data while it's asynchronously validating the request. And there's even a header for that to specify the duration. It's also part of the spec of HTTP. You can specify stale while we validate, and that's the amount of time that the reverse caching proxy will serve all data to the user while you might be doing a potentially very slow reload with a backend system that might be slow or under heavy load. But again, if you use this properly, usually you will reduce load, not increase load, validate quickly, and exit early. And how can you validate quickly without taking on the load of the entire Drupal bootstrap? I would think in theory, store it in something that is fast and that is faster than MySQL. Could be Redis. You could store your e-tags in Redis and go along. Now, originally when developing this talk, I'd say let me school those Drupal boys and girls and show them, because it's all Symfony right these days, how you could do a proper implementation of that. And I wrote some basic code that is an event listener that hooks up into that dispatch event loop and has some methods in place, Redis as a service, as a dependency, and a method that checks the e-tag with the if non-match and makes a decision if it's cached or not. And then I have two methods, a request and a response method, and that request method will fetch it from Redis using a sort of MD5 hash, and so on and so forth. I was like very proud to present this to you up until the point I realized that Drupal 8 already has that out of the box. It's called page cache. It is in there, ladies and gentlemen. This is some of the implementation that is there, and it does all those checks for you. So you don't have to build it yourself, just leverage it. And if you have a reverse caching proxy, you could use that in a very efficient way. Right? Something to write down. If you don't write anything down, but if you have to write something down in your mind, I would say that's the one. The third one is content composition and placeholders, which is very much, again, preaching to the choir kind of thing, but I'm going to do it nonetheless. Imagine this very typical website layout: header, footer, main page, navigation. Let's say in that header you want stateful data. You want a shopping cart or account information from a user. which happens all the time. You're Drupal developers, you probably encounter this a lot, that state needs to be present. Users either need to log in or have a session to do that. Well, if they log in or have a session, there's a session cookie present. And if you look at the concepts of HTTP, or from caching perspective rather, as soon as there's a cookie in play, the value of the cookie matters. That means that the response that you're returning has to vary, has to depend on that value. Normally the identifier of an object in cache is the URL. Well, the URL might serve up other data for other users, so we're a bit in trouble. So in theory, caches will say, oh, I'm seeing a cookie, don't want to deal with that, we don't cache. Problem is that placeholder strategy, it's not really part of HTTP because HTTP will return a single HTTP response. So you're basically screwed because you depend on the lowest common denominator, is not to cache. If one element is not cacheable, your page will not be cacheable if it's a single response. Luckily, there's this thing called placeholders, which Drupal 8 has a lot of, but if you look at it, if you zoom out and look at it from a macro perspective of web development, there's two very familiar ways to do this. Or one familiar one, one not so familiar. This is a familiar one, Ajax. You just take that header and you make an Ajax call, and that will be processed by a reverse caching proxy, and it's up to you to give it the appropriate headers. It could be a TTL that is much lower, it could be a no cache header if that is very real time. It's commonplace, people know this. Edge side includes is another one. Like 10 minutes before I did this talk, I had this lengthy conversation about edge side includes with Wim Leers. I thought it would be great to implement it. Turns out this guy is super clever and figured out that there's so many use cases where this doesn't work, but I'm still going to present it to you from a generalistic perspective. Who has heard of edge side includes? Couple people. Edge side includes, the concept is that you have a placeholder that is interpreted by HTTP. Who remembers, this is edge side includes, who remembers server side includes from the old days? Did you like that? Probably not. That was like that's a long time ago, right? That was pre-PHP, pre-everything. That was your web server parsing this placeholder tag, which was very similar to that, and then render it for you. So you have this sort of dynamic content. Well, that happens in the exact same way, but the difference is that this does not happen at the web server level, but on the edge level. That's why it's called edge side includes. These are things that are processed, let's say, by your CDN or by Varnish. So whenever something is not cacheable, you could throw in this one, and then your edge system, your cache, would say, oh, it requires the header there. Okay, I'm going to load it separately, and I'm going to compose it as it were one single page. But in fact, these are two different routes that need to be called. This is an official standard that was submitted by Akamai, big CDN company, and Varnish can handle it, and there's other systems that can handle it as well. Now, the output is just a composition of all these blocks. You could have an ESI frame for your placeholder for your header and one for your footer, and the rest is part of the main page. And the cool thing is that they're per block that it renders, per resource, there's a separate state, there's a separate TTL, which is quite nice. And the way that the system then knows how to parse it, like in Varnish, one of the best practices is to send a surrogate capability header. And that surrogate capability header explains to the backend system, hey, I'm a reverse caching proxy, and I could speak ESI if you want to. The application can look at that header and do this sort of two-way negotiation and tell the backend, all right, you support ESI, well, I'm going to send you some ESI, and it sends a surrogate control header also with that value, and then sends up a couple of those. And then it's up to the Varnish to process that if it knows that the response that was sent back contained a surrogate control header that contains the ESI. And then, in that way, you can have a non-cached ESI placeholder. Now we reach the point where you have to compare both of them, Ajax versus ESI. Now there are some benefits about edge side includes because they are parsed server side on the edge. So you don't really burden your end user, or be it the browser of your end user, to do extra round trips. Everything happens at the data center end. It makes it generally faster. It's processed on the edge. But there's downsides. It is sequential. So if you have 10 different frames that need to be loaded, those are 10 sequential calls by Varnish. If one fails, all fails, which is not that good. And there's sometimes limited implementation, and it's not that commonly known. Like, I asked you who knows ESI, not a lot of hands were raised. So in theory, it's a really cool concept, but in practice, people still rely on Ajax. Because Ajax is common knowledge, and it's client-side, and it supports parallelism. You can load stuff in parallel. There's easy implementations, all the frameworks are built for it, and it has a concept of graceful degradation, meaning if one of your Ajax calls fails, your website doesn't explode. You can just decide, hey, I don't want to load this specific piece of content. It's better to have 90% of my content presented to the user than 0%. So all these things are compositions that happen at the view layer. And Drupal 8 has implementations for that. One that is popular is dynamic page cache. It's also module, behaves a little bit something like this. It takes the requests from the event loop and it will check if all the policies are right, if it can or cannot serve it from cache. Then it will serve it, and then there'll be recursive cache loads that will load all the placeholders and decide how long to cache it and how long not to. This is all implemented under the hood and uses that concept of placeholdering, auto placeholdering, which could be, I'm not a Drupalist, I'm just reiterating things that I've learned. The details might not be 100% correct, but bear with me, please. You could then have this custom little block where you'll have a sort of render array that is very much interpreted by all of that. And on top of that, or besides that, you have BigPipe. Who uses BigPipe, or who is a big fan of BigPipe here? See, more people than, see people doing like this, more people than ESI in any way. And the big value of that is what I've learned. So I've seen Wim Leef's presentation about BigPipe at DrupalCon Vienna. I liked it, it was like, oh, cool. But it took me up until this year to figure out what the actual value of a BigPipe is. Because what they do, instead of just loading the placeholders via separate requests, they just spew out everything that they can serve already. And the stuff that needs to be loaded happens asynchronously in the end, because they send JSON blocks that will then be parsed by JavaScript. And then you could use a thing we call chunked transfer encoding. Because normally, HTTP buffers what it sends to you, and it gives that a content length. It says content length, X amount of bytes, and that's the stuff that will be sent as soon as all the data comes in. That's your famous first byte. That might be slow, because reverse caching proxy will wait until everything is there. By stating that you use chunk transfer encoding, you'll basically spit out chunks of data as they come in. And in that respect, you can do everything that is very common and cacheable will come first, and then at the end, everything that is slow will be sent as JSON blocks, and these JSON blocks will then be rendered into these kind of things, into these spans that have identifiers, and that will be loaded. And at the end, these blocks of JSON will be used to expose things that aren't cacheable. Now, the problem with BigPipe is not really a problem, it's by design, is that it's not cacheable. It's built for users that are logged in, users that by default standards will not benefit from reverse caching proxy. But I still wanted to mention it because even if you have content that is not cacheable, BigPipe might ease the pain for you. And as you can see, this is VCL code, this is Varnish code, and it says, if the surrogate control header that is sent by Drupal contains BigPipe, it means that you're doing BigPipe streaming, so that means we'll force it to stream it through, we won't buffer it, and we decide not to cache it. That's Drupal for you, ladies and gentlemen. I quite like it. It's not, I was hoping for more simple implementation that would serve it via Varnish and have these interesting tricks, but the reality is sometimes you can't, and you have to ease the pain. BigPipe eases the pain big time. Cache variations. We continue on. You can have cache variations. General question apart from that is, how do you identify an object in the cache? I've mentioned that already. You do that by using URL, basically. Now, what if I told you that the URL varies based on the value of a request header? This is my critical phase, like like, you've seen Jurassic Park? You didn't say the magic word, that kind of stuff. What if the URL, the content actually, like, you go to the home page and it might vary on values that were passed as a request header? For example, the language. You could send, your browser might send the exact language, it might contain English, German, Dutch, and it's up to the system to pick it. Now the problem is, if you don't create cache variations on that, and you depend on it, the first person that goes to it, its language will be stored in cache. So let's say I'm a Dutch-speaking person, I go to the website, go to the home page, it is not stored in cache. Well, what happens? It will take my browser language, it will negotiate it in Drupal if that is present, if those implementations are present, and it will serve a Dutch page, which the reverse caching proxy on its turn will then cache and serve to everyone else, even the English-speaking people, even the German-speaking people. So we're faced with a problem there. Luckily, HTTP has a solution for that. It's called the vary header. And if you send the vary header with a request header, it has to be a request header. If you send that along, then Varnish or any other reverse caching proxy for your caching object will create a subtree with all the variations. Watch out with those variations, because the more variations you have on a certain value, the less hits you will have, and your hit rate will drop. So it's a balancing act between doing it the right way, like varying on the correct header, and also containing the values it can have. Like you can tune in Varnish, you can create white lists and black lists of what you can expect. Because let's say you have let's take that example again, English, Dutch, and German, and you don't have content for Spanish or French people, you'll still create variations of that, which will fall back probably to English. What I would do in that case is apply this certain logic that everything is EN, NL, or DE, and if it comes with another value, force it to be EN. Because in that way you'll contain your variations, in this case 3, and not a zillion amounts. You also need to do a little bit more cleanup in there, because it's not always EN, NL, DE, it might be EN US, EN GB. So there's a requirement there to clean it up a bit, otherwise very weird and exotic versions of languages and of accept languages will screw your hit rate up a big time. So again, vary on a request header that can be validated when the next request header comes in, and it'll be fine. Number 5, content invalidation. Did you know, ladies and gentlemen, that there's only one thing worse than not caching enough? It is caching too much or too long. It's worse. The only thing you suffer from if you don't cache enough is load on the system. But the data you return, the stuff you return, is actually consistent in terms of data. But if you cache for too long and the data has changed in the backend and you have no way of flushing that to the end user, well, then you're serving inconsistent data, which is way worse. You'll have to apply purging strategies for that. And there's a lot to be said and done in terms of Varnish and CDNs and other reverse caching proxies, but we're going to stick with what Drupal 8 offers us. Just a second. Need to refuel before this thing stops working. By doing some reading work, again, I'm not from the Drupal scene, I've learned that the purge and the purger HTTP modules are quite good to do something in Drupal 8 that was not really possible in Drupal 7, be it invalidate based on tags. Because the problem Drupal 7 had, and that, let's say, its simpler sibling like WordPress didn't have, is complex content types. Because those complex content types could appear on different URLs. And when you need to invalidate a value of, let's say, a little block that has changed, you need to be able to know which URLs you need to invalidate in the cache, which is hard labor. Whereas in WordPress is so simple. You only have a post, a page, a category, a tag, you name it. Just as simple as that, and they can just invalidate based on the URL. So they change something in CMS, they save, and then some hook triggers invalidation on very specific URLs. Drupal doesn't have that luxury, because Drupal has a lot more complex content types. So in Drupal 7 it was quite cumbersome to invalidate content correctly. Drupal 8 luckily has a tag-based system. So if you install these modules, you'll end up with all this. I've activated it, I didn't really regret it. And then in your purging part, you have to create an extra invalidator, and I call it the Varnish purge. And then I will define in the next slide what that contains. When those invalidations are added, they will just be part of the queues, and those will be stored in the database queue. And then eventually you can choose how to invalidate the cache. You can do a drush PQ add, or you can purge blocks explicitly, and then these processes will be executed. It will be a queuing item you'll be able to invalidate based on the tag. A cron might clean up your things after you save them in your editor later on, or you can add the late runtime processor, which will actually hook into the save or the add or delete part and will immediately trigger that deletion. How does it do that, you ask? Well, here's the configuration of my Varnish purger. It is a tag-based invalidation system, and here is where I specify where my Varnish is. So it's on the local host, the point of entry is port 80, you can do that. And instead of doing a GET request, you'll explicitly do a ban call after the fact. That's a method that does not exist. It's something that was invented just for the sake of invalidation. It's not part of any spec. We just do it to make Varnish know that, hey, we're not trying to fetch a page, we're trying to invalidate a page. And we're doing that over HTTP. Then the next part is that we'll pass along some headers. And we'll name the header purge cache tags, and we give it that expression. And then based on that, we need to write some code. And what we'll do is we'll catch that ban, as you can see there, and we'll check first if the URL of the IP router is part of purge, and purge is an ACL that I defined here. So only ban requests can come in from the local host, otherwise we consider it bogus, and we don't accept it. What do we do instead? We say 4 or 3 not allowed. Can't really do that. Because if we expose that to the outside world, anyone with a bit of skills could just invalidate your cache and just stampede the hell out of that website, which is not the goal. Once that has been done, it will look at those tags and add them to the ban list, all these tags. And then there's a process, a sort of thread in Varnish that will look at the ban list and say, oh, this needs to be removed from cache. All the objects in cache that match these tags will remove them. And that makes it a lot easier. This is what's being sent by a Drupal response then. Those tags. And it contains very specific users. Like everything for user 1 or all the blocks. And if objects in cache match that, or if a ban expression matches any of those will be deleted. So there's a bunch of strategies you can apply to invalidation. You can go for a high TTL situation. I showed you very early on that you can define a cache control in the admin panel based on a set value. You can do that, but if you do that, you have to have a good purging strategy. Now, these methods, these modules that I showed you do that. Work just fine. You can also do something else, and I see companies that focus on that a little bit more, is have low TTLs. Don't store things in cache for too long, but leverage those conditional requests that I showed you. Invalidate or revalidate a lot more interactions between the backend. But if the data hasn't changed, you'll return a 304 and the cache counter is updated again. Now, what I've also explained to you is that a system like Varnish, and probably other systems as well, will, while you are revalidating, just send the old data to the user, which is okay. And then it will asynchronously revalidate, update the counter, and then the next user will get the fresh data. That's how it works. It's up to you. Choose high TTL strategy or low TTL strategy. We're nearing the end of the presentation, but unfortunately, you're not done yet. This isn't, like, I've talked about the ideal world and the reality. Well, the reality is that we're still faced with these Drupal cookies, and you need to account for them. I've done a Varnish implementation. I'm pretty sure that the admin panel or the configuration suite of your CDN or your auto reverse caching proxy will allow this as well. What this does, this is complicated regular expression mumbo jumbo. But what you need to remember from this is that it will remove every single cookie that the reverse caching proxy receives from the user and will only keep something that matches this regular expression. Ses with some alphanumeric characters, or SS, or no cache. If it sees either of those cookies, it will say pass. So it will remove everything besides that. If the end result is an empty string, if all of it has been removed, I'll remove the cookie and continue. If there's still a session cookie or an S session cookie or no cache cookie present, do not cache this. And that's the only way we do it. We have to compensate for that behavior, and that is something that cannot be done out of the box. What can be done, and I'm not sure that Drupal does this in a correct way, is just leverage the no cache headers. Like if you want to use the value of a cookie, let's say you force your reverse caching proxy to cache every single thing and only respect cache control headers. Well, what you could do then, if a cookie value is required for a page, you can just set a no cache header. But I'm not sure that Drupal does this in the correct way. Now, as a hosting provider, we primarily depend on VCL files to deal with that. So this is a way we tackle this, unfortunately. The world is not perfect, but if you use the proper HTTP best practices, as a developer, your life will be easier and you won't depend on other people so much. That being said, thank you for checking me out. We're earlier than expected, which is good, because you'll be the first one. Is there beer involved later on, or is it just the end?
Yeah, it's the end, but there's going to be like an unofficial party.
There will be an unofficial party, which gets you to the unofficial party quicker. Thanks for checking me out. If you want to know more about Varnish, go buy that stuff wherever you do that. And if you want to stay in touch with me, know more about what I do or upcoming presentations, that's where you do that. Thanks again for checking me out. Thanks again for taking the time. I appreciate it. I always tend to time my talks exactly to the limit I have, so I can avoid Q&A. The reason I have a theory behind that, why I don't do Q&A, because the people who ask questions, a lot of people have questions and don't dare to ask them. So you have to be confident enough to ask the question. And the people who ask the question usually ask very specific questions, tailored around their needs. The rest I'm killer rats ass. So I'll be available, like you can ask questions, I can't dodge them right now, but usually I just walk away and say, hey, find me at the booth or whatever.
Yeah,
but I'm going to suffer through it. So there's a mic. If there are questions, I try to answer them. If I don't know the question, I will forward you to people who know the answer to the question. Fair enough? Yeah. Are there questions or are you just thirsty? Who has questions? After I gave that rant about Q&A, who has questions? I don't think there are questions.
They're tired. They want the.
Oh, we have one question. Great. Are you just stretching out, or do you have a question?
Shande, I'm gonna kill you.
I was preparing for the projection of the voice of the question.
Okay. No question.
Perfect.
So you mentioned all these caching strategies.
Yes.
If you were to use a CDN, is there anything that you need to do additionally? Like, let's say you've got a Drupal 8 site and you've got Cloudflare.
Yeah.
Would there be any specific tweaks that you need to make?
Yes, you do. What I would advise you to do is set. I know a lot of cloud providers and CDN providers have that. There's probably a wizard in which cases you want to cache and don't want to cache. There's probably a sort of wizard. I know that CloudFront has it by Amazon, for example, where you could say, I want these cookies to be stripped off, I want these to be kept. And you'll have to do, let me boot up that slide again for you where I've mentioned this. Like what I'm doing here is stripping off every single cookie, including all the tracking cookies that Google Analytics sends, and only keeping the ones that matter. That is Varnish specific. If you have Cloudflare, CloudFront, Fastly, Atama, you name it, you'll probably have to go into your configuration panel and replicate that behavior. Being as soon as it sees a session cookie of that pattern, do not cache. That's my advice. Thank you for asking me a question I know the answer to. Boost my ego. Oh, there's the next one. This is not necessary.
Actually, I'm just wondering, you've seen quite a few CMSs, I'm sure, quite a few frameworks.
I have.
Are there things that you've seen in one of those that Drupal doesn't get to, and that it could and or should do?
Not
In
really.
other words,
Well, I've seen one example where it makes life easier for you, but only if you were in charge of setting up Varnish yourself. It's like Magento has an extension called Turpentine, and it generates the VCL for you based on context that it knows of. So based on the configuration of your CMS, it's clever enough to figure out, oh, you need that configuration, you need another configuration. And it pushes the configuration to the Varnish server and also persists it to disk. So you have a dynamic configuration based on what happens. And Varnish can offer you that because there's an admin interface, not a visual one, but just a sort of telnet access. I repeat, telnet, not SSH, telnet access. But it has a sort of secret key with some negotiation for it to make it somewhat secure. And there's instructions, remote instructions you can give it. VCL.load, VCL.use. So load a file and validate it if the syntax is correct. VCL use that file and dynamically put it in production. So if you want to go that route, you can do that.
I guess we should read your book and update Drupal to make use of that. That's interesting. Didn't know.
Thank you for helping me with the picture. So yeah, that could be an improvement, but I don't see it as an actual rock solid improvement. Reason why is usually when you've set up infrastructure, you probably have good ops people or a hosting provider taking care of that, and they will advise you on the VCL, or you'll know what the right VCL is and you'll tune it anyway. If, as you, a person that resides in the core of Drupal quite frequently, if you think that would add value, because we had this lengthy conversation prior to this about the do's and don'ts about ESI, if you believe that you could tune the behavior of a VCL dynamically and would draw that to the Drupal module, because that will probably be a contrib module, not core, you might be able to influence the behavior of Varnish without burdening your end user. Cool. That's the only thing. And for the rest, you're doing it right, Drupal. It's all good.
Great. Good.
Any more questions?
No time for more questions.
Okay, 2 questions, 2 answers. I'm happy. Thank you for checking it out. Enjoy the rest of your evening. It's probably not be Drupal related, but alcoholic in nature probably. Enjoy it.
Ooh.